Hello guys, welcome back to another episode of COVID Chemistry. As you can probably see, we are in a brand new studio. I would love to say it is an upgrade, but it seems to be a huge downgrade to what we are normally used to. I don't have my whiteboard, I don't have my nice lab to work in. We are in the confined spaces of my bedroom here in Bangkok. We're all in self-isolation, so we're making the best of what we actually have. We're going to try and follow a similar template to what we normally work with. We're going to work in methodically, looking at our information in a step-by-step situation. And we have a visitor. Come on, come here then. Well, you may as well meet my dog while we're here. This is Pecco. This is my assistant. Okay, I don't know how much use she's going to be, but she's cute anyway. Okay, so today we are going to be looking at Chapter 6, Chemical Analysis, Separating Mixtures. You'll know this from your Key Stage 3 courses where you would have done some work on filtration, crystallization, distillation. So this is a nice recap, very similar work from your Key Stage 3 work within your GCSE course. Paper chromatography, okay, nice definition we want to explain. You would have done the experiment within your classroom where you have your piece of paper, you have your solvent, you have your mixture within here, and you're separating the soluble substances which make up this mixture. Then we're going to do a bit more work on how we can test for different gases. We're going to be looking at testing for the presence of oxygen, carbon dioxide, chlorine and hydrogen. Then we're going to be looking at testing for positive ions, these cations, and testing for negative ions, these anions. So a lot of information, but if we work slowly, if we work methodically, it shouldn't be a problem for us guys. Okay, so first some quick definitions we want to be able to state within this chemical analysis, this Chapter 6 content. A pure substance, so it's a single element or a compound. It is not mixed with anything else. Next one we want to look at is our melting point, quite self-explanatory, our melting and our boiling point. So the melting point, key terms, the point at which our solid is turning to a liquid. Our boiling point, okay, the temperature at which our liquid turns into a gas. Next on formulation, very key term for GCSE. Okay, the production of or the design of something in order for its use within industry. I think on here I've mentioned a few things. We have our cleaning products, our medicines and our fuels. Next one I want to talk about is chromatography. I mentioned that a little bit before. Paper chromatography is the one we always talk about within the GCSE course, and we can find what we call the RF value from this. And our RF value indicates how soluble a substance actually is. And we can make a calculation depending upon how far our substance has travelled up our piece of paper. Okay, and the calculation we need to be able to state is our distance moved by our substance divided by our distance moved by our solvent. Okay, so as I said before, we're in a new studio, but we're trying to follow the same method as we did before. We're taking our time, we have some nice tables to work with, we have our definitions, and then we can link them back to things that we have done in the classroom. So I'll step out a little bit. I think I'm getting a bit of a reflection here, maybe blocking it. So I'll step out, you can pause the video and you can make any notes you need to. Okay, so let's have a quick check back. So separating mixtures and paper chromatography there, that's nice and simple. We've incorporated a few definitions there, which is great stuff. Next one we're going to look at is testing for gases. So testing for the presence of chlorine gas. You'll know from electrolysis you would have used this certain type of paper. Testing for the presence of hydrogen, this squeaky pop test. Testing for the presence of oxygen and carbon dioxide. So let's have a quick reflection on what you would have done in the classroom and the tests and the positive results you will have to prove for the presence of these gases. Okay. So the ones we need to know, not in this certain order, any order you want. So we have our hydrogen, oxygen, carbon dioxide, and our chlorine gas. I mentioned before we talked about for testing for the presence of this chlorine gas within the electrolysis experiment that you would have done in the separation of this copper chloride electrolyte. You would have used some litmus paper to test for the presence of this chlorine gas given off. Another very popular one used within the classroom, you may have used straws to blow into your lime water to hopefully produce this cloudy white emulsion colour. Our next one, we're going up in this direction, testing for the presence of oxygen. We're going to take a glowing splint, mix it with this oxygen. If it's present, our glowing splint will relight, okay? Oxygen being within our fire triangle. And finally, hydrogen, a burning splint, and you will have a squeaky pop if hydrogen is present within your environment. So 4 gases, we need to show how to test for the presence of this. So lots of information so far. Initial separation techniques, no problem. Definitions to relate to this. Testing for the presence of our gases. Now we know how, now we want to be able to state how we can test for the presence of our positive ions. You would have done a flame test in the classroom, I imagine, and when you're spraying these different positive metal ions into your Bunsen burner, it would have shone a different colour. A very difficult experiment to do, so you need to look closely when doing this. But let's see the positive test that we need to know. Okay, so a variety of positive metal ions: lithium, sodium, potassium, calcium, and copper. There's no easy rhyme that I know of in order to remember these. It's not like I please send lions, cats, monkeys, and zebras into lovely hot countries, signed Mr. Penguin or signed General Penguin. We just want to be able to state the colour that is related to these metal ions. So lithium is going to turn a crimson colour, like a reddy orange colour. The presence of sodium with our flame test, we're having a yellow. Potassium is lilac. Calcium is a similar orange reddy colour to our crimson, and copper turns a green colour. This is very important that you need to be able to talk about this information in your exam. So I apologise if I'm blocking it here. I'm going to squeeze out a little bit so you can pause the video and have a look at this information. So our positive metal ions, how we can test for the presence of it, our flame test, squirting it into a Bunsen burner, and what is going to happen, or the colour change to identify which ion is present. Okay, right, and finally, I have an extension challenge for you guys. I'm not giving you all of the information. You have to give me a little bit back as well to prove that when you are self-isolating like everyone else in Bangkok, you are doing a little bit of work also. So I want you to be able to tell me a bit of information from the next slide. You are going to go away and identify what we mean by a carbonate and what we mean by a sulfate. We have these negative ions here, a carbonate, a halide, and a sulfate. We want to be able to show what we are adding to these and the observation that takes place to identify the negative ion involved. So one we have here is a halide. A halide is a negatively charged halogen. You know your halogens from your periodic table. You have your chlorine, your fluorine, your bromine, your iodine. These halogens, okay, they exist in pairs. So your negative ions. So my task to you, what is a carbonate and what is a sulfate? Adding our reagent to these and testing for or the observation that comes with this to prove for the presence of which ion we have. So a popular exam technique, or popular exam question should I say, is we observe a certain situation taking place. In the classroom, a student sees fizzing and the releasing of carbon dioxide. Identify which negative ion it could be. So this is the kind of way they ask the questions like this. Okay, so quite a short chapter here, which is nice. Let's just go back and have a review what we need to know for our chemical analysis. Separating mixtures, that's just a basic key stage 3 concept which we know already. Distillation, crystallization, filtration, evaporation, no problem here. Paper chromatography, calculating these RF values from your paper chromatography. Another type of chromatography that you can look into for a bit of high GCSE work going into A-level course is called gas chromatography. If you want to do some extension work, please have a look into this. Then we went on to testing for different gases. So how can we test, or how can we show for the presence of carbon dioxide, hydrogen, oxygen, and our chlorine? Testing for our positive ions, these different colours with our flame test, and finally the reagents and the observations involved to prove for the presence of certain negative ions. Okay, so your homework task is involved in what is a carbonate and what is a sulfate, and then finally I would like you to complete the summary questions on pages 88. If you complete them, an extension task for you to complete is start having a look at the more difficult questions on page 89, these practice questions. Okay, thank you for tuning in once again to COVID Chemistry. This has been chapter 6, chemical analysis. If at any point you need to pause the video or rewind the video, that's what this is here for. Make sure you get your definitions down and your tables. Any problems, please email me. There'll be work in the Google Classroom linking to this. Thank you guys, goodbye.